Good afternoon, my name is GuadalupeJimenezRoano and I'm gonna present the theme of trapezoidal steering on applied mechanisms. To start, most of the mechanisms used in vehicle subsystems are made of 4-bar linkage. Now, what is a 4-bar linkage? This is an individual right member that can have relative motion with respect to all other members. Trapezoidal steering are an example of mechanisms in vehicle systems. Now we are gonna review the analysis of design methods for such mechanisms. An individual right member can have relative motion with respect to all other members is called a link. A link may as well be called bar, body, arm, or a member. Any two or more links connect together such that no relative motion can occur among them are considered a single link. Relative rotation or translation, it happens between two connect links via remote loop or prismatic joints, and this occurs about a line called axis of joint. How we can see in the picture, two links are connected by a joint where their relative motion can be expressed by a single coordinate, and usually joints are typical revolute or prismatic. A set connecting links to do a function is called mechanisms. A linkage is made by attaching and fixing one link of a mechanism to the ground. The fixed link is called the ground link, and there are two types of linkage: closed loop or parallel, and open loop or serial. In vehicle subsystem, we usually use closed loop linkage, and open loop linkage are used in robotic systems where an actor controls the joint variable at each joint. A 4-bar linkage is shown in the figure, and link number 1 is the ground link MN, and the link is the base and use the reference link. We measure all the variables with respect to the ground link. The link number 2 is the direction MA, and usually the input link, which is controlled by the input angle 2. And link number 4 is the direction NB, and usually the output link with angular position number 4. And link number 3 is direction AB, and is the copper link with angular position 3 that connects the input and outputs link together. On the right side, we have the functions that we can use for the angular position of the output and copper links, and are functions of the link's length and the value of the input variable, and the angles can be calculated by the functions. Now in this part we have more explicit how direction affects the mechanisms, and we have another equivalence, and where G1 means D divided by A, and G2 is D divided by C, and now respective, but we measure a closed loop for a bar linkage by a vector loop, and the direction of each vector is arbitrary. However, the angle of each vector should be measured with respect to the positive direction of the x-axis. The vector expression of the link in shown table, we can see then here is all for we can understand more how is function the mechanisms. This is simple. We're gonna start where the or direction be more easy, or direction is to connect for the earth, because in this is the movement. Now here we have all the following. First, the vector love in global coordinate frame is G. How we can see GR4, GR1, GR2, and GR3 all need to be zero. And in this we have all the equations of the terms of GR1, GR2, GR3, and GR4. And the left sparing G reminds that the vectors are expressed in the global coordinate frame attached to the ground link. And now we're gonna substitute the characters in expression for the plan and vector in equation, and this result like this part. Then we can we can see in the vectorial plan with I, G, and K. To derive the relationship between the input angle 2 and the output angle 4, the corporate angle 3 must be eliminated between equations and transferring the terms not containing angle 3 to the other side of equations, and squaring both sides for the following equations, that B sin angle 3 is the same than minus A sin angle 2 C sin angle 4. All these elevate or 2. After by adding equations and simplifying, we derive the following equation, and we have J1 cos angle 4 is blah blah blah, where G1 have an correlation that we can see, and this is called a Freudenstein equation. And the Freudenstein equation to may be explained by using trigonometry. To provide a more pathological equation, than is the following, where A, B, and C are functions of the input variable, and the equation is quadratic in than angle 4 divided 2 can be used to find the output angle 4. To find the relationship between the input angle 2 and the corporate angle 3 and the output angle 4 must be eliminated between the equations, and can be transferring the terms not containing angle 4 the right hand side of the equation and squaring both sides provided. Now we simplify and derive the equation, and we have the no equivalence, and they may be explained and transformed into the following equation.